Hello and welcome to a new episode of the Kubernetes series. We've stopped this series because we wanted to progress with the Path to DevOps series, which is the other one on this channel. But right now, in order to progress with Path to DevOps, we have to learn a bit more about Kubernetes, which is why we're back on this series again. So today, we're going to demystify config maps and secrets in Kubernetes. Now, if this sounds fun, you know the drill. Let's jump straight into it. The first topic on today's agenda is config maps, which, according to Kubernetes developers, are API objects designed for the sole purpose of hosting non-sensitive information as key value pairs. So as you can see here on the screen, when you create a config map, you can store key value pairs inside of it. This is an overly simplified model, but what you need to keep in mind is non-sensitive information, key value pairs, and also don't make it bigger than 1.04 megabytes of data. Also, if you want to consume a config map or your workload needs to consume key value pairs, then you're in luck because the developers designed it to be consumed in three different ways. Environment variables, so you can import each key value pair from a config map as an environment variable in a pod. You can import it as command line arguments, or you can have it as a config file in a volume, which will be mounted in your workload. Moving forward, let's dissect the config map to understand more about it. Even though, to be honest, config maps are quite boring objects in my opinion, because there's a lot to using them and playing with them to understand how they function and how to use them properly in your workload. But in terms of theory, they're quite a simple object. They store key value pairs. So if we look at this object, which I actually extracted from the official documentation, you will see that it has three identical fields as all the other objects we've discussed so far, like pods, services, deployments. They all have the API version, the kind, and the metadata fields. But config maps and secrets have data or binary data, the fourth field, instead of spec, as for the other objects we talked about before. So pods, services, deployments, stateful sets, whatnot, they all have API version, kind, metadata, and spec. And config maps and secrets have API version, kind, metadata, and data or binary data. Data is either stored as UTF-8 strings, while binary data is obviously binary data. In terms of capabilities, we have a few examples here. You can look at the player initial lives, which is an initial key in this config map, and its value is a string which contains the integer 3. Then you have UI properties, file name, and this is also a key that maps to one value. But later on, which says file like keys, you have keys which are followed by a pipe, and then on the next row you have an indentation equal to a tab, and then you have multiple values under the same key. And basically that notation using the pipe teaches the config map that the key which it follows, in this case game.properties or user interface.properties, has to behave like a multi-line string. Okay, that's the whole beauty of it. Okay, time to jump into a demo about config maps and understand what they're all about. I'm going to open VS Code, and if you want to follow along, you can find all of these YAML manifests in my GitHub account, which will be linked down in the description below. So if you feel like following along, it's okay, I got you covered. And don't sweat about it, this is actual official documentation config map. So I haven't made a lot of changes. As you can see here, this is the actual config map example that you get on the official Kubernetes config map page. And that we talked about a bit earlier. And as I said, it has two keys that are key value pairs, and then it has two other keys that are multi-line strings. And we will ingest this config map, or the information from this config map, in a pod called config map demo-pod. And we will ingest them in two different ways. If you scroll down, you will see that first of all we have two environment variables, and as you can see here, first one is called player initial lives, and its value will come from config map game demo, which is actually the name of our config map. And it actually inherits only one key from this config map, the player underscore initial underscore lives, which is this one here. The following one, UI properties file name, is this one from the config map and inherits the property with the same name from that config map. And then we also mount the config maps two other properties, the multi-line ones, as volumes. Yeah. So let's try this out and see how it all looks. I will pull the terminal up here and I'll just copy the path. And if we do kubectl apply -f for file and enter, there we go. We have a config map and a pod. Both were successfully created. And if we do kubectl get pod, you will see we have the config map demo pod running for 8 seconds now. Let's describe this pod so you can see its environment variables. kubectl describe pod. And if we scroll up, you can see that there are two environment variables. Yeah. And it says set to the key of this config map. Okay. So you won't actually see its value here, but let's enter the pod. kubectl exec -interactive /bin/bash, and bash isn't in here. Let's see. Okay, sh is. So if we do a print env, there you go. Player initial lives equals 3. This is an environment variable that we injected into the pod using the config map. Yeah, so it sources the information from the config map. And there was another one. Yeah, UI properties file name. There we go. Okay, so this is here again. And also, if we look at the volume mount, there you go. The mount path is /config. So if I do ls in the root, you will see there's a folder called config. So if I do ls in config, you see two files in here, one called game.properties and one called user-interface.properties. So if we look at the config map, you will see that these two keys are actually being treated like, let's say, files, and the values inside of them, let's look at that. I will cat game.properties. There you go. Yeah, it behaves like a file. Let's cat user interface.properties, and you get the values as here. Okay, so you can use config maps to inject configuration into your applications. That's the whole purpose of it. Just make sure it's not sensitive information. Okay. And speaking about sensitive information and how to store that in Kubernetes, we have a different API object from the Kubernetes development team, which is secrets. And these are also key value pairs, but they're designed to store sensitive information because they also hash that information. So as you can see here, also key value pairs, but hashed, and also the size limitation of 1.04 megabytes is in place. But aside from that, you can also consume secrets, just like config maps, either as environment variables or when pulling images for a pod. This is quite interesting because there are scenarios where you might need to authenticate to something to pull a Docker image. For example, a remote registry. If you're not pulling from a public Docker repository and you're pulling from your own private one, you need to authenticate against that. So you can use a secret to store credentials for that Docker registry or Docker repository and pull the images into your Kubernetes cluster using that secret. And also you can obviously mount the secrets as config files in a volume. Now, the caveat about secrets is that their basic implementation is to base 64 encode. So when earlier I said that they hash the key value pair, they base 64 encode in order to hash that. And obviously, if you can Google base 64 decode, you can find out what the secret holds as information if you have access to that string. And taking that into consideration, you might want to design your cluster so that not everyone has access to your secrets. Okay, so the considerations you see now on your screen are there so that you can implement them into your cluster in order to achieve better security. So try to enable encryption at rest, design your role-based access control in such a manner that not everyone can get the information from inside a secret so that they can't decrypt it, and even try to use external secret providers. Because by using that, you pump up your secret game. Instead of using base 64 encryption, which is quite average to be honest, you can use a better encryption mechanism. So having said that, let's move on to the demo and use secrets in action to see what they're all about. And we're back in VS Code. It's time to deploy the two objects from the screen. First one being a secret. And as you can see, this secret has an API version, a kind and metadata field, but also it has a type field, and there are a few types of secrets that you can deploy. This one is opaque. You can also use a Docker type of secret to authenticate against the registry, as I mentioned previously. So if you want to learn more about secret types, read the official documentation on that, please. But you also have the data field, which contains two key value pairs. The first one is username, which as you can see is a human language readable string. And then you have something that's base64 encoded. And then you have the password, which is also human readable. This is the key, and the value is also base64 encoded. And the second object that we should deploy is the pod, which will consume at this location here a volume that comes from a secret. Yeah. So this is basically the crux of it. We deploy a pod which consumes the secret above. Let's do that. Copy path, kubectl apply -f, and there we go. This was already created. The pod is configured. Let's look at the pod, kubectl describe pod, and as you can see, the pod has a volume called foo and is of type secret, which means is a volume populated by a secret, exactly what we wanted to obtain. So let's do an exec inside of the pod to see how it behaves. My pod was the name, bin sh. Okay, so if we do cd inside of, I think it was etc foo was the location, and then we list, you can see here that we have two files, let's say, which are the password and the username. So let's see what's inside of them. Okay, so the username was admin all along, and let's cat the password as well, and this is the password. So let's check if this is true. I'm going to exit our pod, and now that we're back in PowerShell, let's base64 decode these strings to see if this is the actual right information. So base64, and in here, if we want to decode, let's decode this one. There we go. This is admin in human language, and this should be the password that I set. There we go. Yeah. So basically secrets, as I said, key value pairs where the key is human readable and the value is base64 encoded. Thank you so much for your attention so far, guys. As I said, if you want to follow along on these tutorials, all the materials are on my GitHub account. You just need to follow the trainings repository, and in here Kubernetes, and there are a lot of lessons that are taught on the channel already or are in the progress of getting created and being taught on the channel in the future. Thanks a lot, guys, for giving me your time of the day so far. If you have suggestions or questions about the content, please leave a comment down below. I'll make sure to reply to you. And I would like to wish you a great rest of your day. See you next time. Cheers.